Uh,
All right, good morning, everyone. Today's June 1st. Can you guys believe that?
Yep.
Yeah,
I'm gonna have to.
last month of the year. Okay.
Wait, did you
And
steal all these questions from Khan Academy?
these are questions from Khan Academy. That's right. So, like I've said in the pacing calendar, as well as in the message that I sent you all, we are moving away from Khan Academy's I'm moving away from having Khan Academy do the data management, and I am finding that Google Classroom's data management is a little more useful for my sake. So which is why I'm switching the format here. So from now on until the end of the year, okay, you are going to be working out of the Google Forms that I create, and you will still be able to see the results, okay, like you would in Khan Academy. And you're allowed to redo these forms if you find the degree of accuracy is not to your liking. You can always redo the form until you're satisfied. Does that make sense? So let's
And
say you
you'll
get
record the latest score.
say that again. I'm sorry.
And you'll record the latest score.
And I'll record the later score. That's right. Okay. So so you get to do this as many times as you wish until you get it perfect if you like. Okay, that's fine by me. Um, which is what Khan Academy sort of has anyway, right? You get to do it so many times, and then if you mess up, they give you a hint. The only difference is the Google form will not give you a hint. Okay, I will at the end, show you what you got wrong, but then you got to go back and you got to try and redo it. Okay, so that's really the only difference, and that's it. Why don't we get started? So I'm going to present with my tablet and just give you a little notes here. Give me a second while I grab the stylus. Okay. So so I want to present over here with my tablet. Okay. Okay. Let me erase all this. Okay. So I want to give you guys a little notes, okay? If you do not have the Google form opened up at this point, like I did a moment ago, you should certainly have that opened up, and you should also have a sheet of paper and pencil handy, okay? While I give you the information, the background information, to be able to answer these questions, okay? So this is what you're going to do. The scenario that was given to you in that problem look like this, okay? And we have a diameter, okay? And within the circle here, there's a triangle that's drawn, okay? So if you recall from the work that you did in the week before, okay, in all the weeks leading up to this week, what kind of angle is this angle called? Starts with letter I.
Inscribed angle.
It's an inscribed angle. It's an inscribed angle. What do we know about the relationship between the inscribed angle and the intercepted arc? What do we know about the relationship between the inscribed angle and the intercepted arc?
The intercepted arc creates the inscribed angle.
The intercepted arc is, what was that again?
Creates the inscribed angle.
It doesn't create it. It has.
It's half the inscribed angle. No, the inscribed angle is half it. The inscribed angle is half of the original angle.
Excellent. So I'm going to write that down here, okay, in case you forgot that. So the inscribed angle is 1/2 the intercepted arc. You should definitely write this down if you don't remember it. So if the inscribed angle is half of the intercepted arc, okay, which is what we had discovered, okay, like maybe a week to 2 weeks ago, okay. So let me ask you, what is the measure of the intercepted arc here? What's the measure of the intercepted arc?
180 degrees.
That's 180 degrees. Everyone agree with this? This is 180 degrees. Ian, do you know why it's 180 degrees?
Because it's an inscribed angle. Because it's basically this is diameter in a circle.
It's a diameter. That's true. That's absolutely right. Okay. It has a
diameter measure of 180 degrees.
Right. Wait, Chris, do you know why it's 180 degrees? Why that arc in green is 180?
Think I might.
That arc in green is what portion of the entire circle?
Half. And the entire circle is 360.
Yeah, so that arc in green, if the horizontal line, like Kian said, is the diameter, what portion of the entire circle is the arc in green?
Half.
It's half of it. So Kian, you got that? Right? Yep. It's the diameter, so that arc in green is half of the circle, so therefore it's 180 degrees. So Michael, what must be the angle? What must be the inscribed angle?
180 degrees.
No. The inscribed angle is the angle that's in pink. The intercepted arc is the angle that's green.
Is it 90 degrees?
It is 90 degrees. So here in this case, okay, the angle that's in pink there, okay, this must be a right angle. Okay, that must be a right angle. So, which leads us to another theorem, okay? And what exactly is a theorem again? It's a theorem again is something that's built off of other known facts, okay? It's built off of other known facts. So I'm going to represent this, okay? So we know that this is true. I want to redraw this diagram again, but in a slightly different orientation. Again, I have a diameter here. Let's say I draw the triangle looking like this, okay? I'm coming. What has to be this angle there? Again, I'm dealing with that longest.
It's also 90?
It's also 90.
Yeah,
it's also 90. Okay, so that's also 90. Wait, I want to draw this situation one more time, right? So let's say I draw it like this now, okay? Where I orient it like so. What's this angle now?
90.
It also is 90. So wait, what's the generalization that we can make here, guys? What's the key generalization here? That any triangle inscribed in a semicircle will be what kind of triangle?
Right triangle.
There you go. Okay, any triangle inscribed inside of a semicircle will be a right triangle. Okay, so this angle over here will always be a 90-degree angle. This will always be 90. This will always be 90. Okay, so any triangle inscribed in a semicircle will be a right triangle. And again, this theorem could not have been figured out without this fact here, right? So again, this is a theorem. This is another theorem. Okay. All right. So I'm going to play with this idea a little more. Okay. So I'm going to draw another circle here. And this one here, it's a little more out there. Okay. So I'm going to draw a triangle, not a triangle. This time I'm going to draw a quadrilateral. Okay. So is this quadrilateral actually, before I ask the question, I'm going to label this A. I'm going to label this B. Okay. So this quadrilateral that I have right now, is this any specific kind of quadrilateral that we studied? Like, is it a square, rectangle, rhombus, trapezoid, kite? Is it any of those things? Does it look like it?
It looks like a trapezoid.
It looks kind of like a trapezoid, right? The only thing is it's not. Just because all the sides. Okay, all the sides. Okay, in order for a quadrilateral to be a trapezoid, you have to have at least one pair of sides being what?
Parallel. So we don't know. We don't,
right? Because we can see. I think it's I think you're looking at these two sides, right? Having somewhat of the same slope, maybe. They don't have the same slope. Same thing could be said about these two. And you can see just by eyeballing that the length of the sides are actually not the same either. So none of those properties, okay, involving the quadrilaterals that we studied during school will apply to the situation, which is purposefully done. Okay, so this is just a plain old quadrilateral that doesn't have any special properties. All right. So now with that said, okay, with that said, what is if I draw a line, if I draw a line connecting these 2 points like so, right? If I draw a line connecting these 2 points like so, okay, does that line have to be the diameter?
No.
It doesn't have to be the diameter. It could be the diameter, but it doesn't have to be, right? All right. Now, my next question to you, okay? You see the arc? Actually, you see the arc that's in pink right now?
Yep, I see it.
Okay. That arc in pink, what will be the value of the arc in pink? Will it be 2A or will it be 2B?
2B.
2B.
I want you guys to look at it again.
2A.
It should be
2A.
2A.
Huh?
Emmett,
How's it
why?
2A?
Why is it 2A?
Because it's like A opens up to that.
A opens up to that. I love that description. Here,
It's
look.
also opposite, right?
In case you can't see that, guys, I'm going to redraw it over here, okay? I'm going to redraw it over here so that you guys can see it. Now watch this. Michael and others, right?
Right.
So I want to erase this. Okay. Wait, isn't A? What's the name? What kind of angle is A? It starts with letter I.
Inscribed angle.
It's an inscribed angle, right? The intercepted arc is how many times greater than the inscribed angle?
Twice.
It's twice as great, or you can think of the inscribed angle as being half of it, right? Either one. Okay. So, what about the arc that's in green? What's
2B.
what's the angle measure of the arc in green?
2B.
It's 2B. All right. So let me ask you guys, what is 2a plus 2b equal to?
360.
Say that again.
360.
That's right, Chris. Here's another follow-up question. If 2a plus 2b is equal to 360, okay, is there a common factor that I can eliminate from both sides?
2.
2. And Chris, what will that turn into if I eliminate a common factor of 2 from both sides?
Now be a plus b equals 180.
I was just about to say.
Thank you, Kian. So a plus b will equal to 180. Interesting. All right. If you don't see this, if you don't see what I'm talking about right now, I'm going to try to point that out to you guys. Okay. I'm going to redraw that circle one more time. Okay. And the scenario was one more time, this right here. Okay. And I'm just going to get rid of some of the distractions. Okay. If I have A and if I have B, okay, these two angles right here that I'm going to highlight in blue. Okay. So this guy right there and this guy right there. Those two angles are opposite one another. Is that right?
Yes.
Okay. What will be true about any quadrilateral? Okay, where opposite sides where opposite angles, okay, inside of a quadrilateral, inscribed inside of a circle. What has to be true about those opposite angles? Those opposite angles must be, they're not equal, but they must be what?
Congruent.
Equal to 180 if you add them up.
That they must be supplementary. They must add up to 180. So gentlemen, right? So a quadrilateral, let me write this down. A quadrilateral inscribed inside a circle will always, and emphasis here on that word always. This is like a fact, okay? And you can't get away from it. It will always have opposite angles supplementary. That is a fact, gentlemen. Okay? So again, this is a theorem. Okay? And I'm going to highlight this.
Thank you.
Okay? You should definitely have this, okay? Because that was the derivation of it. Okay? I'm going to give you guys a moment to write that down.
Wait, what were the notes for the previous one where it says any triangle inscribed?
Oh, sorry.
No, it's fine.
Everyone have this before I move on. I want to address Kian's question because I want to scroll up.
Can I screenshot this quickly?
Yeah, go ahead.
Thank you.
No problem. And the other thing that you were asking about was this, and I am going to again box this guy. This is the other idea, big idea that we talked about in this during this office hour session.
Is that all we did? Is that all of it for today?
Is that all of the ideas for today? I want to hit on one other smaller concept, but those are the two big ones. But if you notice, right, these two ideas here all spring from which concept?
Inscribed angles and intercepted arcs.
It all stems from the inscribed angle equal to half the intercepted arc. Very good, Michael. Okay. So all of these, okay, are what we call in mathematics. They are the derivatives, right? They come from, okay, something else. Okay. Everyone have this?
Yep, I have
Yeah.
it.
All right. Okay. So I'm going to hit on just one last idea. Okay. One last idea. And the scenario will look like this. All right. So check this out, right? I have a circle now. And in the circle, I am going to draw two chords with an inscribed angle, like so. Okay. And I'm going to call this A. And I am also going to draw another angle, like so. And I am going to call this, and I'm going to call this, actually, no, that's not good. I'm going to draw another angle over here. Yeah, I think that's better. Okay. And I'm going to call this angle B. Okay. All right. So, do any of these chords have to be a diameter?
No.
Like, for example, does this chord here have to be a diameter?
No.
It does not have to be a diameter, okay? Nor do any of these guys. This is not a diameter, okay? This does not have to be a diameter. Or this, okay? None of these need to be diameters, okay? My question to you, and I need you all to think about this, okay? What is the relationship between A and B?
B looks twice as big as A, and B is like a reflected version of A also.
Okay, so there's a hypothesis that Michael is suggesting that A may be twice as big as B. Is there another hypothesis out there?
It's reflected. I also said that.
You said it's reflected. What do you mean it's reflected?
If you draw a line between A and B where it meets, and if you reflect it, it's going to look like it.
So you're
If you
saying
draw
the
a
two
line.
so you're saying the two triangles there are congruent?
Yeah.
I don't think.
No, I wouldn't say it's doubled.
I
They're
mean,
similar.
like there are two angles right there that you can see are vertical angles, but the two triangles.
I don't think they're congruent though.
Michael, they
Okay,
could be
so I do
similar,
agree
but
with what
they
Chris is
can't be
saying,
good.
that those two angles must be the same because they're vertical angles. Okay. All right. Is there anything else that we can observe about angles A and B? I'll give you guys a hint, okay? And what I'm going to do is I'm going to draw this arc right here.
I think I took the wrong class.
Who was that?
Is that you, Ricky?
No, Ricky's been
No.
muted.
All right, so I have that arc drawn in pink right now, okay? What do we know about that arc in pink?
But it should be 2 times the like the opposite side of it. Like
It should be it should be double that of the inscribed angle, right? So wait a minute. If that intercepted arc is double the inscribed angle, what do we know about the that arc? Should it be 2A? Should it be 2B? Should it be like should it be something else?
well, we don't really have a measure for that. Like we don't have any points or anything, so we don't really know.
So guys,
Let's make it C or something.
so guys, this arc right here, okay? If you don't see this, I'm gonna make it a little less distracting. Okay, so check this out. I'm gonna get rid of this. I am going to get rid of this and focus on just that, okay? So guys, what's the measure of the arc that's in pink?
A.
It's 2A, right?
Right.
All right, I'm gonna do this one more time. One more time. And this time I'm going to get rid of this guy. And I'm going to get rid of this thing. What do we know about the arc that's in pink?
2B.
2B.
That's 2B.
So that means that we have two angles that are congruent from that.
So wait. I think Emmett sees it now, right? Do you guys agree with me that all the arcs in pink right now, okay, are they the same?
Yes.
All the arcs that are in pink, they are the same. So therefore, what can we say about 2A? What is it equal to?
2B.
It has to equal to 2B. So going back to my original question, what's the relationship between A and B?
They equal each other.
They equal one another. A and B have to equal one another. Okay? So if you're looking at me like, what are you talking about, Mr. Chan? So look, going back to this diagram right here. Okay? So if I have two inscribed angles and they intercept a common arc, then the two inscribed angles will be the same. Okay, let me write that out in words. So one more time, I'm going to move this over. So this should say equal, right? So inscribed angles intercepting the same arc are congruent. Okay, so that means these two angles in green are going to be the same. They intercept the same arc. Those two angles, they hit that arc in green. Those two must be the same. This is the last idea for today. Okay?
All right, got it. I'll just take a screenshot. Got it.
Cool.
So what does that idea mean? Does it mean both of the inscribed angles must hit on the arc, the
So,
highlighted arc?
thank you for asking a clarifying question, Michael. Everyone have this before I move away from it?
Yeah.
Hang on.
Wait, Mr. Chan, I also
Yeah.
have a question like about the course. What happens to Delta Math now?
Delta Math we never got to, so don't worry about it.
Yep,
Wait,
no need to
I
worry
mean-
Can I
about
see the
it.
notes below that?
The
So
note-
we're not supposed to finish Delta Math, or we are?
you don't have to finish it. No,
I mean, I already did. So.
you did. See, that's why you are always like the leader in any group discussions.
Thank you.
I'm kind of like the caboose, the last guy.
No, you're
Everyone
just-
have this? Yes.
Wait a minute. I just need to get it and done.
All right. So now look, let's check this out, right? So these are the three main ideas here. Okay. What I'm going to do now is just elaborate a little more on this last concept, which Michael had asked about. So that last concept there. Okay. So Michael and others. Okay. If I have the situation where I tell you that this angle over here is 30 degrees, okay? And I'm going to give you another angle over here, okay? What has to be that angle there?
An inscribed angle.
Do both of these angles intercept the same arc?
Yeah.
Yeah.
So what has to be that angle?
30.
That's
30.
it. That's all it is.
Oh.
That's a direct application. That is a direct application of what we just talked about. Okay?
Oh, okay,
Inscribed
got it.
angles intercepting the same arc are congruent. Those two angles, those two inscribed angles, they intercept the same arc. They are congruent. Okay, so now that I've
Mhm.
gone through all this with you guys, okay, let's take a look at that Google form. I am going to stop presenting over here
When is that
And-
form due? Is it due today?
tomorrow.
Oh, tomorrow. Okay.
All right, so now let's take a look. That's the first question, right? So that first question there, what do you notice about angle C? What has to be angle C, guys?
90.
90.
Love that, Chris. If angle C is 90 and we know angle A is 46,
And it's
What
got to be
hap-
44 because that adds
Yeah,
up to 90.
we already put in 44.
that's 44. All right.
Easiest question ever.
Well, I mean, it wouldn't
Not
be easy
ever,
if you,
but-
if you didn't know that fact that I told you, right?
Okay.
Okay. So let's take a look at the next one. What is the measure of ISE? Angle ISE. Okay. Angle ISE.
Mhm.
So we already know that one angle equals to 27.
Yes.
So then we can use supplementary angles to find out what what 61 like the other angle is. So you could subtract 61 from 180, which is 119.
Yep.
So
119.
And that's SIE. SIE.
So let me ask you this, guys. Wait, SIE. That's right, SIE. What's the measure of angle SIE?
119.
119. Guys, what are we gonna do with 119 and 27 then?
Add them up and then subtract them from 180.
That's all you do. add them up and subtract them from 180, okay?
Got it.
Wait, 119. Where did we get that number from?
61, 180 minus 61. See, it's supplementary with SIE.
Oh, okay.
Right? So if you take 119 and 27, add them up, and then you subtract it from 180, what do you get?
34.
34. All right. Okay. So we want to know what is the measure of arc VU. VU. Okay. So we know that SV is 120, right?
Yeah.
If SV is 120, what is the measure of arc SU?
44.
No. SU, arc SU, SVU, that is, SVU. You notice that they gave us at angle T is equal to 82, right?
Mm-hmm.
If angle T is 82 degrees, what is the measure of arc SVU?
It's also 82. This is
No,
what
it's
vertical angles.
100 and
8.
no.
Wait, no, 108. No, wait.
SVU. SVU.
It'll be
For
98,
SVU,
right?
They have to add up to 180.
No.
It has to be-
All right. So let me pause here and elaborate a little bit then. So let me present screen again over here. So this is the situation. So I have this right now. Okay. Whoops, it's not a circle. All right. So I have this situation. Something like that. Okay. Where this angle here is 82, right? My question is, what is this arc? Let me get rid of this. Let me get rid of this. What's that arc?
An intercepted arc.
That is the intercepted arc. What's the inscribed angle?
41.
No.
Why?
It's got to be doubled. So 164.
Oh, okay.
Say
Right.
that again.
It's 164.
It's 164. This has to be 164. Very good, Kian. Okay, so this
Okay.
is 164. So if that is 164, right? And the question was, wait a minute.
No, and we already know that 120 of that is SV.
Yeah. So
So it's 44 then.
That is 44.
right? Because this guy over here is 120. Okay. So I want to stop presenting over here. Okay. Back to this. And last one. So the question here is, what is angle R going to equal to? What do we know about opposite angles inside of a quadrilateral inscribed in circles?
They're congruent.
No, they're not congruent. Look at the notes that I gave you today.
They equal 180.
They add up to 180. So if opposite angles are supplementary, R happens to be opposite of which angle?
R is opposite of angle E.
R is opposite of angle E. And angle E measures how much?
74.
So if angle R is opposite of angle E and opposite angles are supplementary, what must be the value of angle R?
106.
It's got to be 106. Cool?
Lee Brown, baby.
But Mr. Chan, when I completed the form,
Yeah.
it didn't say it didn't automatically say it was done because I guess you can resubmit as many times as you want.
It didn't say that it was automatically done?
Yeah, like I had to write mark as done so the assignment would go away. So that must mean that because you can resubmit, it doesn't do it.
Yeah, you need to submit both in the Google form as well as like in the assignment itself
Do you just
have
click
it
mark as done? Is that all you need to do?
Say that again, I'm sorry.
Do you just click mark as done and not actually need to click anything?
I think that's
All right.
it.
That's what I
Let me
did.
let me try to. Okay. Let me go over here to see what it looks like.
What was the answer for the third one again? I wasn't actually quite paying attention there.
What was that, guys?
What was the answer for the
Yeah, I know. What, does anyone know?
I'm gonna have to look again. I'll pull it up real quick.
Let's see here. Google Form.
It was 44.
As I thought.
44, thank you.
I just did the problem on my own recently, and yeah.
Huh?
Yeah.
Michael did not respond.
Is that all we
Yeah.
need to do, Mr. Chan? Or do
That
we
was all
have
you needed to do. That was all you needed to do. And look, I get to see the results here. I get to see the
just the
results.
form? I haven't done mine yet.
You should do it.
I'm just about to turn mine in.
Yeah,
just
I'm in
doing
the process of doing mine now.
You just turn it in?
I mean, I said I'm in the process of doing it right now. I'm doing it right now as we're speaking.
Okay. You should have done it while we were going through it live. Let me check on.
Yeah, that's also what I'm doing.
So right now I have 3 people turned in. Okay, so who are the 3 that just turned in? I have Katie Kirk, Emmett, and Kian. So you guys need to turn in the form, okay?
So one
Got
of the people wasn't even on this thing.
That's right. Katie was doing it outside of office hours. Okay? But you guys not only need to hit submit, but you also need to hit turned in. Got it?
Got it.
Yeah, got it.
Okay. And let me see here. The responses, the individual responses. This is really cool. Okay. All right. So I'm going to stop recording.